Thanks for joining us. My name is Peter Klein. I'm an account manager here at EView. I'm joined by our CTO, Chip Sutton, and our managing director, Trent Gregory, who will be presenting today's webinar. We'll be presenting the EView iSeries and Mainframe solutions and how they seamlessly integrate into Splunk. A few of you did ask some questions ahead of time. Thank you. We'll be addressing them during the presentation. Feel free to ask any questions at any time. We will share the response with everyone unless you guys request us not to. It's going to be short and sweet from my point of view, but Trent, if you can pick up the mic and go ahead and get us started.
How you doing? This is Trent Gregory. I'm a general manager here at EView Technology. I appreciate the opportunity to everybody take out of your day to learn a little bit about EView and then our solutions specifically for the Splunk platform. As you heard from Peter, what we're going to do is I'll just spend a few minutes going over a little of the high-level slides, marketing about kind of who we are, what we do, our customers, and then really get into the technology with the demo from Chip Sutton, our Chief Technology Officer. And from there, during the demo and whatnot, we can certainly, I don't know how we'll handle questions, but we'll let Peter moderate that. So with that said, just as an introduction, for those of you who don't know too much about EView, is we've been around since 2000. Our focus has been on developing, specifically developing solutions which integrate the IBM Mainframe and iSeries, now IBM I, what used to be called the AS400 environments, into the leading enterprise platforms. We originally started off with the HP with their operations manager and extended our technology over the years to include the HP UCMDB Discovery, as well as the Microsoft System Center platform, and as well as Splunk in recent years. So the whole purpose of our software is really to give a consolidated single point of view of the enterprise with these platforms. Typically, as many of you know, the mainframe and iSeries for AS400 environments have been more of onto, hate to use the word, but silos onto their own. And just the way today, in today's environment with the hybrid cloud and all different infrastructures out there, the mainframe and iSeries need to be part of an overall solution. And that's where we come in with our expertise in providing that. So from a credibility standpoint, as I said, we've been doing this for many years. We've got hundreds of customer installations in over 35 countries worldwide. We have a proven support infrastructure. We're based in Raleigh, North Carolina, but we provide support 24/7 around the world to all of our customers. We also have within our testing and development environment multiple IBM Mainframe as well as iSeries and a host of other machines to be able to either test the latest and greatest versions of the IBM operating systems or Splunk, whatever comes about. So we are an IBM business partner and development partner, as well as development partners with Splunk, Microsoft, and HP. And so this chart here, as we see, those are our various products across the different platforms that we support. I think to the next slide, it's more of an eye candy slide, but it really shows how we leverage our, we call it the EView Intelligent Agent technology that Chip will get more into in a few minutes regarding what we do. So we are focusing on IT operations intelligence, IT operations BSM, and discovery, which is part of configuration management with our products. So again, for today, we're specifically focusing on Splunk, but for everybody's other knowledge that we do also have support for these platforms and looking to expand into other platforms. This is just some of our top customers around the world that we have. Very proud of it, from our many names that you recognize here. Go on to the next slide. Don't want to spend too much time on that. Just reiterating that some of the advantages of our technology is it's proven. with the EView Insight product for Splunk. We are the only ones in the marketplace that integrate both the IBM Mainframe and iSeries environments seamlessly into Splunk. From a cost perspective, we're truly looking at, we're not on a Splunk model where it's, pay as you consume. It's a one-time license fee price, and we price it per physical machine, and then just an ongoing annual support cost, which covers any new upgrades, enhancements to the software, as well as any technical questions that you might have, any problem solutions, bug fixes, the standard things. Then I will probably, for lack of time, get more into, if we can go to the next slide, Chip, and I'll turn it over to you to really discuss our intelligent agent technology and how it works.
All right, thank you, Trent. Before we actually go into the demo, I'm just going to go through a few slides. The first slide here is just to show you what our architecture looks like and how we integrate with Splunk. You'll see on the left side of the architecture slide here where we show either the IBM Mainframe or the IBM iSeries AS400 system. We do have what we do call our intelligent agent. All of our integrations are based on this agent technology. We've used the same agent technology since the year 2000 when we did our first integration into the Hewlett-Packard Operations Manager platform. And we've continually expanded this agent technology to be able to do additional integrations like we did for Splunk. There is a key design point with our agent technology. It is designed to be very low overhead. Essentially, what our agent is doing is gathering data and then pushing that data over a TCP/IP connection to a server that we call the EView collector. This is either a Windows or Linux server that also has a Splunk forwarding agent installed on it. And on the collector, we take the raw data that is sent over from the mainframe or the IBM I system and format that data into a format that can be ingested by Splunk and sent to the Splunk indexer. A little more detail on the agent, as I mentioned, it is designed to be a lightweight agent. We do have filtering capabilities. This architecture allows us to integrate with multiple platforms, which is one of the reasons we use this type of architecture. Since it is a multi-purpose agent, we actually do have customers that are using the same agent to send data to multiple platforms, not just Splunk. We do have a filtering capability on the agent that it helps you control the amount of data that's sent over to the collector. It's a basic level of filtering based on certain parameters about the type of data that is being sent, so that you can control how much data is sent to the collector. And then on the collector, when the data is formatted, there is an additional opportunity if you wanted to do additional filtering before it goes to Splunk. Instead of using a universal forwarder, you could also use a heavy forwarder and then do additional filtering at the collector level to control the amount of data that goes into Splunk. We've tried to create the architecture and be sensitive to the fact that, especially in terms of the Splunk product, that you are paying for the amount of data that gets indexed. So we want to give you multiple ways to be able to filter that data, control how much data gets indexed to Splunk, so that only the data that you actually need gets indexed by Splunk, and that you're only paying for data that you need to have in Splunk. Another key aspect of this architecture is via this TCP/IP connection between our agent and the collector software. We do have protocols that allow us to recognize when data cannot be delivered by the agent to the collector. This protocol will do things like heartbeats to make sure the connection is available, but it also does message sequence checking so that between the collector and agent, the agent knows that message has been successfully delivered to the collector. And if not, then the agent can either retry that data, or if the connection is not available, then the agent will buffer that data and hold that data until that connection is established, and then deliver that to the collector. So data that you're collecting, and depending on getting into Splunk, we do have a very high reliability of getting that data based on the different protocols that we use and buffering techniques that we use to get that data over into Splunk. So the last couple of slides, I'm just going to talk about the types of data that are being collected from the mainframe ZOS system and also from the IBM I system, and then we'll go and actually take a look at some examples of the types of data that are being collected. On the ZOS system, we'll start with that. The main type of data that we're collecting is console syslog event data. So anything that goes to the system console or the system syslog, for example, like operating system data, DB2 messages, JES2, CICS, WebSphere MQ, and other types of messages that go to the console or syslog, any of that data can be collected by our agent and sent to Splunk to go into the Splunk database. We also have an interface for SMF records, so there's different types of SMF record data that can be collected. For example, information about jobs that are running, job data, RACF, IBM security product, that type of data can also be collected, CICS data set activity, and other types of SMF data that are collected and sent over to Splunk, and we'll look at some examples of that type of data as well. Performance data, if you would like to collect performance data, the agent has an option to be able to get data from IBM's resource management facility, their RMF1 system metric data, and send that data over to Splunk. You can configure how often that data gets collected and sent to Splunk. And then something else that we have a lot of customers that use this type of interface because especially in ZOS environments where there are many different applications, many different tools that are in place, we have something we call a custom message interface that can be used to instrument batch job streams that can be used from existing automation tools. It could be coded inside a CICS transaction. A number of different ways that this custom message interface can be used to send your own type of messages to Splunk. This allows you to get the data into Splunk using our agent interface and then our transport technology that makes sure that the data is successfully delivered over to the collector and then into Splunk. Now on the IBM I or iSeries systems, we have a number of different sources of data that are relevant to those types of systems. The first area that we get data from is message queue data. Message queues are the way that in the IBM iSeries world that data is delivered to the operator is through something called the system operator queue, or for AS400 iSeries people, that's typically known as QSysOper. But there can also be application queues, message queues. If you have other software products, they may use their own message queues to deliver messages. So any of the message queues that you want to get data from and forward that data into Splunk can be configured, and the EView agent on the AS400 will monitor those message queues and then pick data up from those message queues. Just like on the mainframe, we do have ways of doing different type of filtering of that data, so you can control based on things like message IDs, message severity, which types of data are sent from the iSeries system over to the collector and then on into Splunk. Another important area for many people is security type data, which comes from the system audit journal. Security related events are monitored in real time. As part of our filtering capability, you can choose which types of security events from the audit journal you want to collect and have those forwarded to Splunk. The history log, there are some types of messages that don't go to any of the standard message queues, but are written directly into the history log. So we have the capability of our agent, you can configure it to monitor the history log and capture these types of messages that do not go to other message queues. You can also configure the agent to collect system performance data. So data information like CPU, memory type data, disk type data can be collected and forwarded over to Splunk. And then similar to the mainframe, there is the ability to send custom data by creating a user message queue and sending custom messages to this message queue to get any other type of data that you wanted to send via the agent into the Splunk server.
So while Chip's bringing up the demo, I'll just add a couple more comments. As you can see from what he's talking about, the agent is very comprehensive in what the data that it gets out of the mainframe and the AS400 systems. Additionally, there was some talk prior to the call about, there is the pressure that a lot of the resources, specifically in the mainframe, are, they're becoming more and more limited. And that's one of the, I would say, not necessarily a design point, but the points of our software is to be able to bring the ability to get that information from the mainframe, which is highly specialized, into more of a general tool such as Splunk that can be consumed by IT department as a whole. So really, I mean, there is a level of expertise to get it set up and installed and running. However, once that gets going, the data will flow to be used by the rest of your enterprise.
What we'll do for the demo is go through some of the types of data that are collected from the IBM Mainframe and the IBM iSeries systems. When you install the software, we also provide Splunk apps for both mainframe data and iSeries data. Part of what you will have with the Splunk apps will be any types of data mapping that need to be done specific to that type of data, as well as dashboards that can be used right out of the box to start visualizing the different types of data that are collected. So what I'll do is just talk about some of the different types of data and dashboards that are available, and then we can go and look at some examples of this data. I'm going to actually start at the bottom here, ZOS messages. This is event data that typically goes to the ZOS console or syslog. So what we're looking at here are the different types of messages that have been coming out onto the ZOS message, and you can see that they look very much like they do in the syslog. One of the advantages of getting this type of data in Splunk for anybody that's tried to go back and look at syslog data from a previous day or previous days or even previous weeks is this data typically gets archived, and if you need to go back to a certain period of time, typically the process of looking through this data means restoring this data from archives and then going through and then doing basically finds through a 3270 type interface to look for this data. It can be a real advantage to have this data in Splunk and then have this data indexed, because you can go through and very quickly look at syslog data, not only from one system, but if you need to look across multiple systems, then you have all that data archived in one place within the Splunk system. And you can then go and look at details of these messages, do any kind of typical searches that you might do as far as the types of data within the message. We go back to here, and now we'll go back up and look through some of the types of data that are collected from SMF, or the System Management Facility, which collects data from a number of different ZOS components. One area that we get data from is CICS, specifically related to CICS transaction response time. So when we take a look at this dashboard where we're looking at CICS data, in our dashboard here, we can see different transactions at different times. can go in and we can even identify peaks via this graph to see when a transaction took a longer period of time. And then we can also go down and look specifically at specific information where we can see not only the elapsed time of the transaction, but we can also see information that might give us an idea of why the transaction was taking so long. So for example, we can look here at transaction here where the file IO time was a long time, resulting in longer response time for the transaction. I'm going to go down and just drill down on one of the transactions events, just to show you a little bit how this data gets formatted. And what you'll see here is that the data that's going into Splunk has been formatted using JSON formatting, which makes it easy to be able to utilize any field that's part of the message, but this can also be used if you want to do additional filtering. So for example, if you were looking for filtering on specific CICS regions or specific transactions, you would be able to do that, using the JSON fields and building the filtering specific for this data. Another area of SMF that the agent collects data from is data set activity. So if you have a need to have data on mainframe data sets, how often they were accessed, when they were accessed, any of that type of data, then you can configure the agent to collect what are called the data set records, SMF 1415. We also support VSAM data set information or SMF record collection as well. So you can get information about when data sets are accessed and information about those accesses. So if we go down and drill down into the data where we see a particular data set that's been seeing a lot of accesses, we can go into this data and then see more details. For example, we can look, for example, at see what job was accessing this data. We can also find out, how many disk devices that data set is on and how much activity that got on that particular device. So there's a lot of information that's available as part of these records that you can get into more detail as far as the data set activity. Another area for SMF data that many customers want to look at is what jobs are running, how often they're running, how long they're running. So this particular dashboard is looking at individual job information, where we're looking at jobs, when they started, when they ended, how much CPU time they used. And ZOS systems, if you're using workload management, be able to see which workload in service class that job was running in. We can also drill down and see additional information about the jobs as well that's not shown on that particular dashboard. So for example, we can look at by data set, or what's called by data definition name, kind of IO activity was going on with that system. And we can drill down on any of these different categories to see a lot more detailed information about the particular jobs. One of the things that some people might want to do with this type of data, besides just being able to look at individual jobs and information about the jobs, would be to go in and do some type of reporting. For example, looking at CPU time and what jobs are using the most CPU time or elapsed time, or looking at things like average CPU time or average elapsed time. So this is a dashboard that takes that SMF data that's gone into Splunk and then gives another visual representation of that data to gives more of a summary type representation as to jobs that are using CPU time, elapsed time, et cetera. So just one example of how this data might be used within Splunk. The system level performance data. This is a dashboard that's showing just some of the metrics, for example, CPU utilization, a snapshot of the most recent CPU utilization, and then also CPU utilization and other metrics over the last 24 hours. So here we're looking at things in addition to CPU utilization, the common system area frames, which is a memory indication. Here we can see that that this is running pretty steady, but when we go over and look at available frame count for the last 24 hours, we can see that during a period of time, the available frame count started dropping, which is an indication that the memory is starting to get utilized more. Different ways of using the system performance data, visualizing that data. The resource access activity is data that's coming from the IBM RACF product, which is the IBM security product. Currently, we can also support, if you're using top secret, data from top secret as well. In this particular case, what we're looking at are security violations, but any other type of RACF event can be looked at. So something that part of security monitoring would be important, or for auditing, if you're using RACF to audit data set access, that type of data from RACF would also be recorded and sent over to Splunk and can be viewed in this dashboard or viewed in any other type of security reporting that you do. So those are the some of the main highlights on mainframe data. I'm going to switch over here to look at data from the iSeries, and there's three primary areas with the iSeries that we're collecting data from, and those are from the message queues, which is event type data, the audit journal, and performance data. Message queues, messages are typically sent to messages and identified by a message ID. So here we have a particular dashboard where we're looking at different messages over a period of time. And what we've done here is created in this particular panel a view of all the different message IDs and then which ones were most frequently. So when we look at this, we can see messages, for example, these top two messages are messages that are generated whenever a job starts and a job ends. So it's not surprising that we're going to see these types of messages as the top two messages. Now, these are not always something that you may want, as was mentioned before. This is where the filtering capability comes in. So you can see this is quite a lot of messages just over a short period of time. So if this is a type of data that you would not want to have in Splunk, then you could exclude that through the filtering capability. But we can go down here and take a look at different types of all the different messages here. So if there's particular messages that you're interested in, you're able to go in and do searches and reporting on specific types of message. So for example, this particular message here, it is related to backup, backing up of data. And we can see we had quite a few. So this is something that the whoever administers the backup system would want to be able to take a look at where certain types of data are not being able to be backed up. In terms of security monitoring, system audit journal data is an important type of data for looking at what's happening with the security environment on the IBM iSeries systems. In this dashboard, we're looking at several different types of security audit events that have occurred and they've been summarized by the ones that by the event type. So, for example, the top event type DO here is a delete object event. Any of the event types that are being monitored in the system audit journal can be looked at. So, for example, here we're looking at SV, which is system value events, which means that somebody has gone in and made a change to one of the system values. Certain types of system values that you would want to know about. In this case, somebody's been changing the time value quite a few times, but there may be other types of changes that are made that would be that anybody that's administering or monitoring the iSeries system would want to know about. So, for example, here we can see that somebody's changed the maximum job limit on the system. So this is information related to any type of security information or administration that might be important for somebody to be aware of when changes like that are made onto the system. Any other type of auditing that's being done, such as command auditing, auditing of objects and who's allowed to change that. So if you have any of that type of auditing turned on, any of that type of data could be collected and sent over to Splunk and available for reporting and viewing. And then the last area for the iSeries is the performance data. So here's a dashboard looking at performance data, some of the different metrics that are collected for performance data. This is just a sample of a number of different types of metrics that are collected here for CPU utilization. Here we're looking at disk busy as well, writes per second, and then one of the memory indicators, which would be database or non-database faults in this case, giving us an indication of how memory is performing. This is just created from the individual data. If we go down and take a look at one of the individual records here, we can see there's a lot of different metrics. And over here, you can, on the left-hand side, you can see some of the different types of metrics. So things like, disk busy, interactive CPU utilization, IOs percent, percent CPU used by jobs or number of jobs in the system, response time metrics, a number of different metrics that are available as part of the iSeries data. That's an overview of both types of systems and the different types of data collected and viewed and reported on in Splunk. So I think, Pete, we've got about 20 minutes left on the time. So I think at this time we can go through any questions.
Yeah, if everyone wouldn't mind, if you have questions, please go ahead and send them over, type them in privately and send them over, and we'll answer them in sequence. Of course, if anybody has private questions they don't want to air over the webinar, just send them to us after the webinar, and we'll get back to you with answers right away. There was a number of questions that were asked prior to the webinar that we answered during, so I'm not sure if anything else has come up during the discussion. Can one intelligent agent send data to multiple EView collectors?
Yes, it can. Yeah, so there's a number of different options that can be set up. You can have the agents actively sending data to more than one collector at a time. So if you're want to feed multiple Splunk indexers for some reason, you could do that, or you can have one collector kind of collecting data in a standby mode, but not forwarding to Splunk unless you needed to switch over to that collector. So a number of ways that you can utilize the architecture that allows multiple collector servers to connect to the agent.
Thank you. Next question, any specifics related to using indexers on the cloud? Nothing
really specific. It really, in terms of the collector, it doesn't matter whether you're going to an indexer locally or going to a Splunk cloud instance.
Thank you. Another question, is the EView product offered as a SaaS?
Not currently. We find that most people, even if they're using, the Splunk in the cloud product, that they still, want to control the data locally and have the collector locally and then forwarding the data to the Splunk cloud instance. It's a very easy product to install and to set up. Can be done in a half a day or less in terms of setting it up and actually having data going into Splunk.
Thank you. Next question, does it include support for ACF2 records?
Currently, it does not, but that is something that we are working on to be able to support. ACF2 utilizes a different format for the SMF records than RACF, but it is something that we do plan to support.
Thank you. Another question, is a forwarder an appliance or software, and what capacity is required?
The forwarder is a Splunk's forwarding agent that is used to get data from a data source and then send that data to the Splunk indexer. So when we talk about the forwarder, we're talking about a Splunk software process that's running. The collector is a server that's made up of basically two software components. One is the EView software that is communicating with the agent and receiving data from the agent and formatting the data for Splunk. And then the other piece is a Splunk forwarding agent that would be installed on the same server, and it would be taking that data that's formatted by the EView software and then actually sending that data to the indexer.
Thank you. Another question, assuming the connection from agent to collector is encrypted, they're assuming that it's encrypted SSL or TLS?
It's not either one of those. It's actually, this is something we developed many years ago. It's our own proprietary method, protocol and encryption of the data. So it is not plain text data, but it's not SSL or TLS. The protocol ensures that only the EView software component can connect to the agent and receive data from the agent. And additionally, there are additional security mechanisms. You can configure the agent to only accept connections from certain IP addresses or IP ranges as well.
Next question, is there a time frame when the ACF2 will be available?
Don't have them, but I mean, we can certainly, discuss that offline in terms of, needs and level of interest. We'd certainly like, welcome an opportunity to discuss that further. Typically enhancements to the product are driven by customer requirements, and the more specific requirements we have, the sooner that, we'd like to, put it on, get it into the product.
Thank you. Another question, is it encrypted on the wire?
Yeah, it's encrypted all the way across. So the agent is basically doing that, sending it over, and then it's basically decrypted on the collector itself. So it would be encrypted on the wire.
Great, thank you. It looks like that's all the questions, unless anybody else has anything. What we're going to do, folks, we can certainly send out the slide deck to anybody that would like a copy. We also have a ton of documentation, from install docs, technical documentation, anything you need. We'd be more than happy to send some of that over to you as well. Also, like I said, any questions that you didn't want to have answered in a public forum, we're more than happy to answer them privately as well. Also, we can set up a private demonstration if you have an expanded team that you'd like have this shown to as well. Yeah, so if nobody else has any questions, we want to thank you all very much for your time, and we look forward to speaking with you in the near future. Thanks very much, everybody.
Thank you.
Okay, bye now.
Thanks, Peter.
You're welcome.